Welcome everyone to the design of a procedure for studying tactile stimuli in fencing. My name is Enrique Alvarez. I'm gonna talk about how would you conduct the study for a stimuli in fencing and what are the procedures to apply it to people. So first of all, what you want to do is just click on the icon for the application that we created, and this is gonna open a window that is gonna show all the controls that we are gonna have for the machine that we created in the thesis. So the first thing that you wanna do is fill the data for the participant, and in order to do that we have a window that basically we are gonna put the subject name, which in this case is gonna be Lynette with two N's, right? And two T's. Is female, right-handed, and supination, the study that we're gonna do right now, and non-bouncing. The grip in this case is gonna be a Visconti, but we can select different ones. The age is 41. Fencing rate is 0 because she never fenced before. And then over here, over this line, you can see all these variables that are the variables that we are gonna keep in the data in order for future process to study different stuff for the different studies that we can do with this device. Basically, the application is so flexible that you can put new variables into it. So imagine that she wants to do a study about how the left-handed is placed. We can put like left hand up, and this would be included as well in the columns in our data file. In this case we don't want anything, so basically we just delete it, and this will create this amount of columns in our file. Now basically, once that is ready, we are ready to run the experiment. So the computer is basically connected to this interface box. We have a microcontroller that is connected to the, in this case, a 3-prong cable, and then a USB and a power supply. In addition to the interface, we also have a box that is gonna produce a pink noise that is gonna mask every noise that we are gonna have in the motors, and also we are gonna combine that with earplugs. The other part of the device is gonna be basically two tripods that are gonna hold the device with 3 motors, and also a sensor that is gonna tell us when the weapon leaves the on-guard position. The way this is gonna work, the participant is gonna hold the weapon on on-guard position, and the bell guard is gonna touch the copper component that we have within the spring, and also we have the actuators. There are gonna be 3 motors along the blade that are gonna make some action over the blade of the participant. So basically, whenever the participant gets the stimuli, the participant is indicated to push forward, so it leaves the contact with the copper and touches the pad that we have at the end of the experiment. Now that we have mostly everything prepared to start the experiment, we are gonna give our participant earplugs. This is gonna make her not to hear the noise produced by the motors. And then in addition to that, we are gonna combine it we're gonna use in combination with our pink noise generator that she's gonna use the headphones for that. So she's gonna get the weapon and is gonna hold in the position, in the on-guard position. Now a key important component on this is to maintain the blade at equal distance to the three motors. Now we go back again to the application. In the application we have several buttons that we can use to this, and the main button that we are gonna use right now is the shoot button. The right here in the corner is gonna initiate the shooting procedure. So basically once the shooting is initiated, a message is sent to the device, and therefore it's gonna cause a motor 1 to move, and the participant is gonna throw the touch. You can also see the series of commands have been sent. So basically in this case the command is the 11th, and basically the 11th corresponds to the middle motor. The first number on the left will correspond to the random time introduced by the microcontroller to avoid predictability. The second number, which is 603, is gonna be the reaction time that she had, and the second time, the 1062, will be the touching time. Let's gonna see right now how she does it. Okay, now we are gonna do a shooting procedure again, but we are gonna look at the motors. This case is number 10. It goes, shoot, touches, and comes back to the position. Now let's record another one shooting. In this case number 10. So the first motor is the one that is gonna move, and the person just extends the arm and touches. Let's do it another time. That's good. So all the information that we have over here are gonna be the information that the program is collecting from the participant, and that's the information that we are gonna obtain in our file. Once the participant has finished with all the trials, we can go and look into the data. This is the data that we have collected right now, with the participant name, the number of trial number, all in a text file that can be really easily opened in Excel. So we are gonna open Excel. In Excel, we're just going to open file. We look into text files, linear results. We open our SFXS text file, delimited by space, and to finish. Now what we basically have is the participant name. Then this column would give us the trial number. This one is gonna be the place where the stimuli was placed. So number 2 would be the motor in position number 2, which is the middle. Number 3 would be the foible. Number 1 would be the forte. Now the next column would tell us the random time introduced by the Arduino microcontroller in order to reduce predictability. Column number E would give us the reaction time. The column number F is the touching time, and then the rest of the columns are gonna give us the variables that we introduced in first place in the application.